Right, the final way of showing data graphically is by using something called a histogram. Now, a histogram is actually only used for when we have dealing with grouped continuous data. So when we have like a range, so we can't do it for discrete data. And so what we have on the y-axis is something called frequency density. And we work that out by this equation here. We can see that frequency density is frequency divided by the class width. And on the x-axis is just whatever variable is going to be. So it could be like height, length, weight, whatever the question is going to give you. And so as you can see, it's like a series of bars, and let's make sure there's no gaps in between the bars, and they're all stuck together. And that's just a frequency density histogram diagram. And what we can say is, well, we can actually work out how many people are within this class, or how many people are between or certain classes or less than a certain value, similar to a cumulative frequency diagram. Right, another point we need to note is they might ask you to draw something called a frequency polygon. This is also very simple. So once we've got our histogram done, what we need to do is just join the midpoints of each bar. Okay, so if I write an x bar at the midpoint of each bar at the top, and then just join them by a series of straight lines like this, this is known as a frequency polygon. So if they ask you to draw that, it's just basically joining the crosses together. Right, so there are actually a couple of one-mark questions which I can give you specifically for histograms. And the first one is, what is the characteristic of a histogram? Now, the main characteristic of a histogram is that the area of the bar, so i.e. this area or each individual area, is actually proportional to the frequency of that class. So how many people are within that class? Okay, so that's the main characteristic of a histogram. And so we can say that A is proportional to F, so therefore A is going to be equal to K times the frequency, where K is just a scalar constant, which we can find later on. Another one-mark question would be, why can a histogram be used, or justify the use of a histogram? Well, in this case, we say because whatever the variable is, as I said, like it could be weight, height, length, because that variable is a continuous variable. Okay, so that's also like a one-mark common question we can give you in the exam. Okay, let's try this example here. So we have the variable y, which is measured to the nearest whole number. 60 observations were taken and are recorded below. Write down the class boundaries for the 13 to 14 class. Okay, so for this one here, the class boundaries, as you can see, because there's a gap between 12 to 13, we go that 0.5 below, right? So that it'll be from 12.5 to 14.5. That will be the class boundaries for the 13 to 14 class. Right. A histogram was drawn, and the bar representing the 13 to 14 class had a width of 4 centimeters and a height of 6 centimeters. So first things first, we have to draw our own histogram. So in order to do that, we need to find the frequency densities, because that's the y-axis, right, of each value. Okay. And remember, frequency density was frequency divided by class width. Okay, so for the first one, let's look at this one here. The frequency is 6, and we're dividing it by the class width. Well, the class width is from 9.5 to 12.5, that's 3. So therefore, it's going to be 2. So that's going to be the first value, 2. This middle one here is going to be 24 divided by the class width, 12.5 to 14.5, so 2. Therefore, it's going to be 12. Third one, frequency is 18 divided by class width, 14.5 to 17.5, so that's class width of 3, so therefore it's going to be 6. And lastly, this one here, 12 divided by 17.5 to 25.5, so that's going to be 8, so that's going to give us 1.5. Okay, so we need to work out the frequency densities first. Now we can actually go about plotting it. So for the first one, it's going to be a frequency density of 2, and it's going to start from 9.5 to 12.5. So starting from 9.5, going up to 2, up to 12.5 like this, and then you just draw it like a box, like so. Next value, it's got a frequency density of 12, and it starts from 12.5 to 14.5. So until 14.5, we want to go up to the 12 value here. So it's going to be quite a long box going up, making sure there's no gaps in between the box. Obviously, they're going to give you some graph paper to do it in the exam. I'm just drawing a freehand, so you should use a ruler and just try and draw as accurately as possible. Next is 6, and that's from 14.5 to 17.5, so until here, and so until a frequency density of 6, roughly here. And finally, 1.5 from 17.5 to 25.5. So 1.5 is roughly here, all the way up to 25.5. So this would be our histogram for this example here. Also make sure that you label the x-axis. So as you can see in this case, there is measure to the nearest whole number. So let's say variable y. Okay. Right. So carrying on, so a histogram was drawn, and the bar representing the 13 to 14 class. So the 13 to 14 one will be this one here. They said that it's got a width of 4 centimeters and a height of 6 centimeters. So that means it's got a width of 4 centimeters and a height of 6 centimeters. Okay. And they said for the bar representing 15 to 17 class, so basically 15 to 17 will be this one here, calculate the width and the height. Okay, so it's basically ratios. Okay, so what we can say is, let's go for the width first. So for this 12 to 14 class, the width was 4 centimeters, and that's equivalent to the class width. In this case, the class width is, how much is that? That's going to be 2. Okay, so therefore for this one we're trying to find, the class width is, in this case, it's going to be 14.5 to 17.5, so that's going to be 3. So therefore, it'll be equivalent to 6 centimeters. It's just basically ratios, okay? Let's look at height. So for this initial one, the 6 centimeter height one is equivalent to the frequency density of 12. Okay? So for this one we're trying to find, the frequency density in this case was 6, right? If you can read off here, it's just going to be 6. And so the height would therefore be 3 centimeters, like so. Okay? So that's how you measure or calculate the height of each bar relative to other bars. Right, let's take a look at one more question. So we have some students that take part in an obstacle race. The time it took each student to complete the race was noted. The results are shown in a histogram. Give a reason to justify the use of a histogram to represent this data. So this is like the common question I mentioned earlier, right? So we have to say that in this case, we're measuring time. So we say time is a continuous variable. Okay, so as I said, it's a very common question. So just make sure that you understand or know how to answer it. Right, the number of students who took between 60 and 70 seconds is 90. So basically this here, this area here, there was going to be 90 students. Find the number of students who took between 40 and 60 seconds. So basically we want to find how many students took between here, this area here. Right, in order to do that, we're going to look at the characteristic we looked at earlier where we said area is actually proportional to the frequency. Okay. So therefore I can say that area is equal to some k value times the frequency. And then we need to find this k value in order to find the frequencies of other boxes. So looking at this initial one here, they said between 60 and 70, what's the area? Well, the area is 60 to 70, that's going to be 10 times the height, which is going to be, if we read off here, is 6, right? So 6 is 60. That's equal to some k value times the frequency, and the frequency in this case, they said it was 90. So the k value is actually going to be 60 over 90, which is just 2 over 3. So that's the first thing we should be doing. Now we can actually use this to find the area or the frequencies of the bars. So they said find the frequencies of the students in this box here, right? So we need to find the area first. The area is going to be 20 times the height, which is going to be 5, which is 100. Now 100 is equal to some k value, which we found as 2 over 3, times the frequency we're trying to find. Therefore, rearranging for f is just 100 times 3 over 2. So therefore, it's going to be 150. Okay, so simple as that. Right, moving on. So let's say we have question C. Find the number of students who took 80 seconds or less. Okay, so 80 seconds or less. So what they're trying to asking us to find is basically how many students they're going to be in this total up to this box here. Okay, so basically these 3 bars here. So how many students there are in total? Right, we found out earlier that in this box here there's 150 students. In this one here there's 90 students. So all we need to find is the number of students in this final box here, and then that's going to be the number of students less than 80. So how are we going to do that? Well, it's just basically doing what we did in part B. So we need to find the area first. So the width is 10 times the height. If you just read it off, it should be roughly 8.6. 10 times 8.6 is just 86. We can say that 86 is equal to the k value, which is still 2 over 3 times the frequency. So therefore, the frequency is 86 times 3 over 2, which will give us 129. Okay, so that's how many people are within 70 to 80. So for everyone less than 80, what we need to do is just sum them all up. So we say 129 plus 90 plus 50. So that's going to give us 369 students who took less than 80 seconds. And D, calculate the total number of students who took part in the race. So for the total number, that means we need to find the area of the whole, all the other bars here, basically the remaining ones here, okay? So for this one here, the area, what's the area? So it's going to be 5 times the height, which is 14, which is 70. This one here is going to be 5 times the height, which is 12. So it's going to give us 60. And this area is going to be 30 times the height, which is 3, so it's going to be 90. The total area of these last 3 bars is the sum of these 3 here, which will give me 220. So we can say that 220 is equal to F times the K value. F is therefore 330. Adding this onto here will give us the total number of students, which will give us 699, like so.